Can everyone see my screen? One of you can confirm.
Yes, sir.
Okay. Cool. Okay. So what are we going to learn today? We'll learn. So we're basically, this is the last course of MySQL basics. Okay. After this, I think from next month, we'll start learning about the Spring Data JPA. This is where your Spring application actually connects to a database, and you write Hibernate entities to model after table. Okay. So this is the last session on this, and we don't have a lot of things to teach today. So if you have any questions relating to anything that we have taught so far, you can ask your questions here. I'll be happy to explain again. Okay. So today we'll learn mostly three types of joins. Okay. Inner join. I think it's like inner join, outer, which is also called the right join, and I think cross join, something like this. Okay. After this, we'll learn about the transactions. Okay. In that, we'll learn about committing a transaction. Okay. So in a typical Spring Boot application scenario, you are mostly like or from a databases point of view, you are mostly not going to be implementing these things because you'll be working through Spring Boot. So Spring Boot already has annotations for handling these things, but it's good to know how it happens in the database level. Okay, so the thing that we have decided today is I have actually picked up this tutorial because it actually gives you a sample database with which I can work. So to basically show you what the sample database has, this sample database is basically you can think of it like a sample Amazon. Okay, you have customers, you have employees, you have office details, orders, payments, product lines, and products. Okay, you have a bunch of these things. To demonstrate the join, we're mostly going to be use the order details and orders. Okay, uh, let's just take a look at how the typical order details looks. So I'll say select star from orders. Okay, limit to, and select star from order details. Okay, all right, so your order details has order number, product code, quantity ordered, order line number, price each. Okay, and orders basically have order number, order date required, all of these things. Okay, customer number. So how are these two tables connected? These two tables are connected via order number. Okay, if we want to uh, see the schema of this table, we can issue this command. I just want to show you what data we're going to work with today. Okay, so show create table order details. Okay, orders. Let's run this. Okay, so basically this is, let me just copy this. Okay, so you have order, which has an order number. This is the ID basically, and you can also see that order number is the primary key here. You have order date, required date, ship date. All of these things are not really concerning here, just that these are the things that it has. And then we have something called order details, where you have the order number, and you can see that the primary key here is actually the order number and the product code. So they're basically making these two things as a primary key. It's a complex primary key, and yeah, that's basically it. All right, and they're also setting the foreign keys here. So you have a foreign key, which is the order number coming from the orders table, and then you have the product code referencing to the products table. Okay, let us also take a look at the products. Okay, show table products. I'll give you an idea as to like how these two, how all these entities are connected. Okay, so don't worry about that. Just these two. Okay. So you have basically a customer. Customer is an independent entity, as the customer yeah, well, okay, customer isn't exactly the independent entity. You have a sales employee reference number, whatever, but basically this is a customer. It's a customer, has its customer number, which is the primary key here. Okay, that's all you need to know about a customer. Okay, we'll just see how these are linked together. And then you have product here, which is basically it has a product code.
Hello.
Yeah, Abhishek.
Hello, sir.
Yes.
Your voice is sometimes going down, sir.
Sometimes going down.
Yes, sir.
No, is it better now?
Yes, sir. Now it's
Okay.
better, but sometimes it's just
Huh.
your sound is like up and down, sir.
Okay, okay. Maybe
कभी
it's
कम हो रहा है
this
कभी
thing.
ज्यादा.
I think it has. You see this, right? It's going down automatically by default. I'm not sure what the issue is. I'll have to look into this thing. Anyways, so basically this is what we are dealing with. We're dealing with 4 entities here: customers, products, orders, and order details. There is a customer. You have a bunch of products. Customers contain all the customers. They can actually order any of these products, and this would be an order, and this would be order details. Okay, what is order details? Order details basically, it's like if you ever purchase something from Amazon, you're not going to make an order for every item, right? You're going to add a bunch of items in the cart. That it's alone would, that like all the items together will generate one order ID, and then you can basically place an order. So it works something like this. You order details contains each of the items that you add in your cart, and that summing up when you check out. At that time of checkout, all the order details will have the same order number, and this order number is what is going to be your order ID. Okay, so how are they linked here? If you see here, this is an independent order number, which is the primary key here, and it also has a customer number. Customer number has to be unique. Okay, and they have a foreign key here, which sorry, customer number is not unique. It's just a key here, which means that there will be an indexing on customer number. Okay, are you guys familiar with the concept of indexing? One of you can answer.
No, sir.
Okay, okay, so
And sir, hello.
yeah, yes, Abhishek.
Constraint parts.
Sorry,
Where
sorry.
use constraint, because sometimes constraint we use in primary key, and where we constraint, sir.
Is everyone able to hear him properly, or is it just me for whom it's breaking up?
सर नहीं सुनाई नहीं दे रहा है, तो कट कर दिया है अभिषेक की आवाज.
Acha, acha. So it's breaking. Abhishek, can you just type out the question?
Sir, hello.
Huh.
I am audible, sir.
Yes.
Sir, actually, I'm little bit confused in constraint, sir.
Acha.
Sir, where we can use constraint, because
Acha,
sometimes we are using constraint primary key, I think, and Here we can use constraint as as in foreign key, sir.
So, correct. So see, basically, constraint is you defining the rules for the tables. Okay, when you design a table, you basically say that anytime and any operation happens on this particular table, it has to follow these rules or these constraints. You define the constraint using this thing. So if I talk about the constraint in general, okay, it has basically the constraint keyword. Okay, then it has the constraint name. This is your user defined name. Okay, user defined constraint name. Then you have the actual constraint key. Okay, actual constraint key. Okay, and then you have basically the value of it. Like it depends, like for foreign key it is like this, for unique key it will be something else. Okay, so basically if you have a, if you design, if you have a look at a table, right, for example, if you look at this particular design of the table here, they have added two constraints. Okay, those constraints are basically of foreign key type. They're designing the foreign key here. If you were to make a unique key constraint, you would write constraint. Your details would be, let's say, UK unique key or something like whatever they have followed, order details UK, something like this. Then you would say unique. Okay, then you would give your actual column values there, whatever values you have, and that's it. So up until this part is same for everyone. What do you do with this thing? You basically add rules for this specific table. Okay, that's what the constraint is. So your question is, why do we do it as primary key, and why do we sometimes add this thing? So where did you see primary key being added as constraint? Like I have never used primary key with constraint, but let me just check. uh, nope, like okay, right, yes, yeah, we can use it like this. So see, basically there are two ways of doing the same thing. It does the same thing, right? You can add this because everything, whether it's a primary key or a unique key or indexing or anything like this, that is always a constraint on the table. That is always a rule that the table has to validate. Any type of operation, whether it's insertion, deletion, update, or retrieve, all these operations have to obey by the rules that you define for the table. This is how you basically define the rule. Now there are many ways you can do this thing. This you can do it the old way, like writing constraint order details foreign key and stuff like that, like how it's written here. Okay, constraint pk person primary key id and last name. You can either do it like this to make things simpler or less verbose. They have basically said that if you write just the primary key here, it'll behind the scene it'll generate the same SQL statement. Understood? It does the same thing. You can use it as constraint or you can use it at primary key. For example, if I just want this quantity order to be unique, I can either write it like this: constraint UK quantity. All right. This statement here, right? This statement here is equal to writing it like this. Understood, Abhishek?
Yes, sir.
There are two ways of writing this thing. You can either, when you write this here, you can either write it like primary key here itself. Instead of, you can either do this, or you can define it like this, or you can add a constraint here and define it like this. Okay, so basically different ways of doing this thing. Cool. So let's talk a bit about indexing, because that's an important concept in MySQL, and that will actually help your retrievals become very fast. So What exactly is indexing? First, I'll explain what exactly indexing is. And the second thing is, why is indexing an important factor in any sort of database? Okay. So let me show you something. Phone. Uh, Images. Okay. Acha. Okay. Wait. Another simple example. Okay. Look at this thing. Okay. This image. What does this do? This basically says that if you are trying to understand everything about how to understand maths, it will basically be from page number 1 to 44. Okay. Then if you are trying to do some playful problems, it will be from page number 45 to 106. Okay. Because the next section starts from 107. This is an indexing. Okay. uh, because so what exactly is the purpose that indexing serves? If you did not have this thing, okay, let's say you did not have this thing, you just had an entire book, then you would have to scan every page. You would have to go page by page to find out where exactly a particular topic is. Let's say you are looking for this, the aha factor. You would have to go, like you would have to turn 8 pages before you land on the ninth page, and you know that, okay, this is my aha factor, this is what I'm looking for. Similarly, if you want to go for this thing, you would have to turn all the 108 pages before you can land on this thing. Okay. This is how any SQL database basically reads. They read sequentially. Okay. Like if you do not specify anything, if you just say that select this thing from this where ID is this, or not ID, let's say you have a query like this. Okay. Select star from customers where customer name is, let's say, John. Okay. If you do this thing right, what it'll do is it'll actually go through one by one. Like if we just see the data here, for example, you have all these customers data here. Okay. uh, what it'll do is it'll basically look for the customer name, right? So it will compare all of these things. Like it'll go compare this, then it'll compare this, then it'll compare this, then it'll compare this, all of these things. It becomes a very tedious process, because what if your name is actually lying in the 122nd row? Then what will happen is it will scan all the 121 rows before it reaches. So that is a very time consuming process. Worst case scenario is the name does not even exist in the database. If you're trying to search for a name which does not exist, it will scan all of these things. Okay. All the 122 rows, and then it will give a result saying this name does not exist, which means you are wasting CPU threads on scanning these things for a result which does not exist. Is there a way in which you can make things faster? This indexing is the way to make things faster. Now let's think about it. If you want to learn about, let's say, this particular topic, okay, weaving it all together, you are more likely, the first thing you will do is, instead of going through page by page, you'll come here and you'll check where exactly is this particular problem. This is where it is, and it actually starts from page number 139. So you know that any problem related to this topic, okay, is going to be within the page number of 139 to 160. Okay. Because 161 is where the next topic starts. Okay. Which means you are not scanning from 1. You are going directly to 139 and you're scanning till 160, which means your search scope, okay, the number of rows you have to scan becomes very limited, which means your searches are faster. Is this understood by everyone? It's a very simple concept.
Yes, sir.
Okay. This is why indexing is absolutely important, and indexing is what makes your searches extremely fast. So I'll give a very practical example. Okay, in companies like Flipkart and Amazon, they actually have indexing done on product tags. Okay, for example, if you're buying a laptop, let's say, they have different tags assigned to it. They have electronics, they have laptop, they have PC. If somebody searches PC, it's going to show laptop. If somebody searches laptop, it's going to show laptop. If somebody searches electronics, maybe after 2-3 pages, laptop will come up. So they have done indexing on these tags. Okay, so if somebody is searching for, let's say, electronics, it will basically check the indexing. Let's say the indexing will look something like this. Okay, electronics, it goes from 100. Okay, then the next thing is yeah, let's say electronics goes from 100 to 300. Okay, let's say you're looking for laptops, and laptops are actually even narrower. So laptop will be somewhere from 200 to 300. Okay, something like this. So what will happen is, if you are searching for let's say electronics, it will go and it will scan all of these rows. Okay, now Flipkart has a huge database. Okay, they have millions of products, okay, with millions of tags and everything. So you cannot read the entire database just to search for a Lenovo laptop or an Apple laptop, right? That will take forever. One query will take forever for that, and then they will have to do multiple queries to actually execute a transaction. So to avoid that, they have indexing here, which means the time to search a product or time to search a particular row becomes very limited. You are only going to search for 100 to 300. If you give the tag as laptops, it will search for even less space. It will search for 200 to 300. Okay, this is basically what indexing does. It helps you search faster, but indexing is also something which occupies memory. Okay, because indexing is itself going to take some space, and as your database grows larger, the indexing would also grow large. Okay, so to give you an example, let's say you have laptops indexing like this, laptops ranging from 200 to let's say 300. Okay, then you have mobiles, all the mobile related things are sitting in 300 to 500. Okay, then you have, let's say, iPad. Okay, all of the iPad related information are sitting in let's say 600 to 700, something like this. Okay, so as it grows bigger, you need to do an indexing on indexing. Okay, so what will happen is you can club these three things. Okay, and you can write electronics. Okay, all the electronic information are sitting from row number 200 to 700. Understood? This part, what I just did here, it's very simple. Okay, this is what indexing is. Indexing requires a lot of memory. So this is one of the, I mean, it basically needs a lot of storage, which is not a problem in today's world because there's a lot of storage, like it comes with GB and everything. So storage is not a problem here. Okay, so this indexing is actually done by the key value here. Okay, I told you that there is a so if you look at this thing, right, primary key are two different words. Key is a single word. Also, unique key are two different words. Okay, so the key part here is what does the indexing. Okay, primary part is what basically assigns a different thing. Like primary, make sure that there is no null value. Okay, unique, make sure that there can be null values, but if there is a value, it is only going to be unique. And key just does the proper indexing. That's it. So primary key, it will make sure that your entry is always non-null and it is indexed. Unique key is going to make sure that whatever entry you're inserting is always unique but can be null, which means a null value. If you insert a null value, the uniqueness won't apply. So you can have multiple rows sitting with a null value. Okay, and it will do the indexing. The key part here is it's done just for indexing. Okay, that's a little bit about indexing. Now let's move on to our topic here. Any questions about indexing, guys? So how will this happen? Let's say you're searching for the name John, right? So what the indexing will do is indexing will say all the names starting from A, B to C, D, okay, will be sitting in row number 1000 to, I mean 100 to, let's say 900. Okay, then likewise it'll have all the names starting with JO, and then I don't know, like KO is sitting for like let's say 10,000, row number 10,000 to row number 20,000. Okay, so as you can see, I'm just looking for John. Okay, so it'll basically search in this thing. So search scope becomes limited, search times becomes faster. Okay, cool. All right, so going back to this, as I was explaining, order details, you have order number, you have a product code, you have quantity ordered, price each, order line, basically a particular order details. Like it, for every order item, you can have multiple orders. Okay, you can order in a single order, you can order 2 mobile phones, 1 iPad, 1 tablet, and one fridge. All of those, each of those individual items are going to be part of this order details. Together, they will always have the same order number. We can check this thing in the database. We can say select, just randomly select any database. Guys, is this font too small? Or are you able to see it clearly, these executions?
See clearly.
It's fine? Okay, cool. So you can see here, you have these many orders here. You actually have a ton of orders, like 326 orders. I collected all of these things from like a sample database. And if you want to find out all the order details for a specific number, let's say, give me 1 second. Okay. Yeah, so we can check with this thing, like you can say select star from order details where o.order number, let's say you pick this number. Okay, let's see how many order details we have here. You can see that we have this order details. Okay, so this particular product here, whatever the product code is, has been ordered in quantity of 30. Price for each is this. The order line number is this. Don't worry about the order line number, but basically this is how it is. So we are going to understand joinings here of different tables. Okay, let me go back to this. First thing is left join. Okay, okay, all right. So what is the concept of left join? Okay, the left join basically says that if you have 2 tables, okay, containing, so basically, first of all, in order for you to join 2 tables, you need to find a column which exists in both the tables. Okay, if you look at this example here, table A and table B both have key columns. Okay, that's why they are basically joining on this. So if I write the syntax here of a particular left join here, it will be from, let's say, I'll call it table A as A. Okay, so basically, let's say you have two tables where a particular column exists in both the tables. On that particular column, you can actually execute this join column. Okay, not necessary that this key has to be a foreign key in this. Okay, they can be completely different things, different tables, not necessarily that they would have to be a foreign key. But yeah, you can actually join these two columns and you can do it. So for our order details, we can write this thing, select star from order orders O, orders as O. So as stands for alias. You can either write as or you can just write O. Okay. Left join order. I think this is the table name, right? Order details. Details OD on O dot order number. Okay, this is how you basically do this thing. If we take a look at this, like if we just execute this query, let me see what we get. Okay, you basically get these values here. Okay, now if you look here on the left side, okay, actually let me execute. One second. Let me actually execute these things so you know exactly just these three queries. Okay, so you know the view. Okay, first one is basically selecting everything from order. You can see that this table, which is on the left side, because this guy is on the left and this guy is on the right side. Okay, so on the left side you have order number, order date, required date, ship date, status, and comments, and then you have your customer numbers and everything. Okay, and then you have your order details here. Order details has, again, order number, product code, quantity order, price for each these things. When you join these two tables, what you get actually has all the columns. So it has the order number, order date till this customer number. Till this customer number, it comes from the orders table, and from the order number here on this side, it starts with the left right table, which is your order details. So you have order number, product code, and all of these things. So basically joins two tables and merges them into a bigger table. Okay, you can either save this table as a view so that every time you need to join, you can actually run a query on the view itself, but we'll not get into that. That's the advanced part. Okay, but yeah, this is the left join. So what is the thing about left join? The thing about left join is that if you're like, so let's say you're, for some of the rows, okay, you have the order number here 100 101001, all of these order numbers are there. Okay, and order details may not have all the order numbers. Basically what I'm trying to say here is, if your left table is, or maybe let me give you an example here. Okay, this is your left table and this is your right table. In your left table you have, let's say, 5 rows, 1 2 3 4 5. Okay, these are the row IDs. In your right table you have 3 rows, 1 2 and 3. 4 5 are missing from B. When you join these two tables, okay, you will have all the rows of left table, and for those rows which don't exist in B, you will have a null value. Okay, that's basically what it does. Is this part clear? What left join does?
Sir, can you repeat this thing again, sir?
Achha, yeah, okay, cool. Uh,
And
yeah, any more question?
sir, and your voice is getting low, sir.
Voice is getting low. Okay.
Yeah.
Is it better now? Hello, testing. Okay, I'm not really sure. I have to change my mic. Okay, I'll try to talk as loud as I can. Just bear with me until the new mic arrives. Anyways, so what I'm trying to say here is, you have, let's say, let's actually take an example here. Wait, we actually have examples here. So can we find some examples? Let me see what example these people use. Order details, left join. MySQL left join. What are they joining it on? Join condition. What are they joining it on? They're joining on select customer number, order status from customers. Join on orders. Order customer. Take it. Okay, cool. Let me. Okay, all right. So basically, what am I trying to say here? So let's say you have customer table, right? You have order table. Okay. You have customer CSC1. Okay. This guy has placed an order for O1. Okay. You have C2. This guy has placed an order of O2. He again placed an order for, the same guy has again placed an order for O3. O3. Okay. You have C3 who placed just one order, O4. You have C4 who has not placed an order yet. You have C5. These are newly created customers. They have not placed any orders so far. Okay. Right. So this view that you're looking at is exactly what the left join looks like. Okay. What do I mean by this is, in your customer database, you can have C1, C2, C3, C4, C5. Okay. And in your order database, you will just have values of something like O1, C1. Okay. And then you will have O2, C2. Okay. One second. Let's write it down here. Okay. You'll have O1 mapping to C1, O2 mapping to C2, O3 mapping to C3. That's it. These are the only three. No, wait. This will be O2. Okay. Then you'll have O3 sitting with C4. No, sorry. Sorry, my bad. O3, because customer 2 orders twice. So C2. O4 is sitting with customer 3. Okay. This is what will exist in your database. Okay. This is what will exist in your database. Okay. You can see here that there's a there's a column C1, which is the customer number or customer ID, with which you can actually join these two tables. What the left join does is it basically shows all the rows on this side. Okay, whatever your left table is customer, right? So I mean, maybe let me just type out the query, then it'll help. Okay, select star from customers, left join, customers C, left join orders O on C dot customer number equals O dot customer number. And if you want to understand what I just did here, you can take a look here. Okay, we have the customer table here where we have the customer number, and if you go to our order table here, order table has the customer number. Okay, so these are the two columns using, I mean, this is the only common column using which I can join these two tables. Okay, so when you join these two tables, for all the rows in the left table, okay, which is my customer, because customer is on the left side of this join statement, orders is on the right side of the join statement. Okay, so because of this, what happens is all the rows on the customer table, okay, will be visible. Okay, if they have a corresponding value in the right table, you will see those values. Okay, so C1 here has a corresponding value with O1, so you have a C1 O1 here. Okay, C2 has a corresponding value with O2, that's why you have C2 and O2 here. C2 again has a corresponding value with O3, which is why you have C2 and O3. Okay, C4 has a C3 has a corresponding value with O4, that's why you have C3 and O4. Okay, but C4 does not exist in this database. Okay, there is no combination of order customer in for C4 and C5. Okay, so when you join these two tables, for those rows on the right table, okay, for those entries for which there is no value, okay, for C4 and C5 there is no value on the order table on the right side. For those particular rows on the left side, the right value is going to be null. Is this understood, Abhishek?
Yes.
Okay, cool. This is basically left join.
Yes.
Understood, right? Cool. So that's basically what the left join does. I think the example I took here is actually wrong, because every order will have order details. We should instead check for customers. Okay, so I'll say select star from customers C, left join orders O on C dot customer number equals O dot customer number. Okay, if we run this query, you need to look at this thing. Okay, so your customer table has these columns, right? So the last column for customer would be credit limit. Okay, so let's take a look at the credit limit here. If you go all the way to the left, credit limit is here, right? After this, your order number starts, right? If you look at the order number table here, look at this particular row. Okay, there is a credit limit of 0, but this is the customer number is 125, right? Let's copy this and paste it here. 25. Okay, so for this customer, there exists no entry in the order table, right? That's why all the rows here, starting with order number, all the rows here are null. Okay, we can verify this if we just run this command, select star from orders O, where O dot customer number is 125. Okay, if we run this query, what do we get? We get nothing, which means this customer 125 does not exist. So for the customer 125, whatever value you received here was actually null. Okay. You can see here for that it is null, and then there are other. I think there has to be other columns for which. Look at these two other columns. Okay, for these two other columns, which is just the customer number 168 and 169, there exists no data. That's why you have these two as null. Okay, cool. We'll take a quick 6 minutes break. We'll again come back at 9 o'clock. Okay. Hey guys, I hope everyone's back. All right, so any questions about the left join? Cool. We'll move on to the next topic, which is the right join. Okay. So what you have learned in left join, the right join is exactly the opposite of that. You can say the right join is sort of like like if you just reverse the tables, that's what the right join would look like. Okay. For example, here, this is what my customers are. This is where all my customers' data are sitting, and this is where all my orders are sitting. Give me 1 second. Huh? Yeah. Okay. So basically, what I'm trying to say here is, if we go back to our definition here, you can see that right. So here you have C1, and basically you have customers here, and then order details here. Okay. Now, if you had an entry where, let's say, how do I explain? Let me actually take their example. It'll be easier for me to explain. So for right join, which are the two tables that they have taken here? They've taken employees and customers. Okay. All right. So we'll have to introduce the employees database. Okay. So show create table employees. All right. Okay. These are the two tables we're dealing with. So let me just go ahead and, okay. This is for the employees part. Okay, so what do we have in employees here? Okay, you can see that we have the customers and we have the employees. So the concept here is that not every customer is going to be an employee. In Amazon, if you work in Amazon, let's say you're a software engineer in Amazon, you are an employee of Amazon, and at the same time you're a customer of Amazon because you're also purchasing things from Amazon, right? So that makes you basically a customer in this thing. I, as a person who is not an employee of Amazon, I will be sitting in the customers database because I purchase from Amazon on a daily basis, but I will not be sitting on their database as employees. Okay, that's basically the funda here. And if you look at this example here, here at this point, they have basically joined on the sales employee number and employee number. Okay, so if you look here,
Sir, your voice is breaking, sir.
Voice is breaking.
Hello.
Yeah.
Yes, sir.
Voice is breaking. Okay, 1 second. I have no idea why this is the. This looks fine. I'm not really sure. Give me 1 second. I'll stop sharing the screen for a moment. All right. Can you hear me now? Abhishek,
Yes,
can
sir.
you? Okay. Cool.
Yes, sir.
Yeah, I think the internet is weird. Like it's been acting weird for the last couple of days. So just bear with me. Stop me if you did not understand because of this connection. I'll repeat again. Okay. So
Okay.
basically, you have your employees and customers, and as you can see, customers have these things. They have customer number, customer name, all of these things, and then they have something called sales representative employee reference number. Okay, if you read here, it says the column
Sir,
sales.
please screen, sir.
Oh,
Screen is
shit.
not visible.
Shit. Yep. I forgot showing the screen once again. Thank you, man. You can see it now. Can you see it now?
Yes, sir.
Yeah,
Yes, sir.
yes, sir. Yes.
Okay, cool. Thanks. All right. So basically, we're dealing with, like I said, I am a customer of Amazon, but I'm not an employee of Amazon. So what is this example telling here? This example is telling that in this customer, there is something called sales representative employee number. Okay. So basically, this column in the table of customers links the column employee number to the employee. So basically, let's say you work in Amazon, and Amazon says that because you are our employee, will give you some discount. Okay, so for the customers, they have added a column called sales rep employee number, which if it has a value in the customers table, that means this guy belongs to Amazon as an employee as well. Okay, so with that thing, you can see that not every customer is going to be part of your employee database, right? So if we do a join on this, okay, so we just they have here they have just taken these two columns. Okay, we'll also follow the same thing. So what they're doing is they're joining the customer with employee. Okay, and they're basically saying that sales representative number, whatever there is going to be with employee. Let's just see what happens here. Okay, let's execute this command here. For now, I'll just say select. The table number is customers. Okay. Right join on C dot sales representative number equals E dot employee number. Okay. If you look at the definition of this table, in the customers, this particular number sales is actually a foreign key to that employee's employee number. Okay, cool. So let us execute this query and see what happens. I think they also right. Okay. Order by E dot employee number. Okay. In the, let's say, ascending order, ASC. Okay. And there's a huge ton of rows, for which what we'll do is we'll limit these things to we'll just select C dot sales representative number, comma, E dot employee number. Okay, this will give a much narrower view. Okay, look at this. So in the left join, what we saw was that the left table basically had the focus. Okay, so if a value existed in left table but the corresponding value did not exist in right table, it was coming as null. In the right join, the table is, I mean, the focus is reversed. It is reversed from left to right. So for every, like, you will have all the rows of the right. Okay, but in the left, wherever you do not have a corresponding value, it will come out as null. That's basically it. It's like this example here. This example here is equal to writing a left for this. Like if I had written this, select E dot employee name C dot sales rep employee number. Okay, from employees E left join Okay, customers C on E dot employee number equals C dot sales representative number. This query here, okay, if you also include the order ID, order by E dot employee number ASC, okay, basically a right join here, this query here is actually equal to this query here, okay, which is a left join and this is a right join. So right join, the focus is on the right table. Left join, the focus is on the right table. Right join is basically the reverse of left join. If you had reversed the tables and then did a left join on them, you would get this, the same exact results, okay. That's basically the left join and right join. Any questions about this, guys? Cool. If there are no questions, let me move on to the next one. Basically inner join, okay. We you can learn about the cross join later on, but Spring Boot cross join is not used much, okay. So we'll just go with the inner join part, okay. So if we look at this diagram here, we learned about the left join where all the rows from the left table are visible, but the right rows are null. In the right join, the right rows are visible and the left rows are null. Inner join is basically the intersection of this thing, okay. Like if you are working with two tables, whichever values are common, only those values are going to be visible, okay. So I mean, if I just do this here, I'll just okay, I'll use the same thing. Instead of right join, I'll just say inner join. If we run this now, you can see that only those rows have been picked for which there's a corresponding value in this thing. So this basically picks the intersection of this. All right. You have few more other joins. You have the you have the full outer join, then you have cross join. You guys can read about those things. That's not a problem, but I will skip them because these are the three primary joins that are used in Spring Boot. Okay, unless you write a custom SQL query out of the box, you will get this one, and this one. Okay, cool. That is for the joining part, joining the tables. Let me go ahead and teach you about transactions. Okay, so I guess you guys are familiar with the concept of transaction. Transaction is basically a set of MySQL or any kind of SQL queries which are going to behave like a single unit. Okay, if you issue a select command, update command, delete command, and you club them together as a transaction, then all three of those statements are going to have to be successful in order for the transaction to be considered as successful. Otherwise, if any of those steps fails, it is going to be the entire unit is going to be reversed back. Okay, that's basically the definition of transaction. So very simple thing. How do we start a transaction? So basically, this is the MySQL documentation here. There are three things you need to learn and understand. You have so you can start a transaction by saying start transaction, and you can issue multiple commands here. Like you can see here, they have issued a select statement, then they have issued an update statement, and then they basically do a commit here. If something fails here, okay, then they basically issue the rollback command. I think the rollback command for this is that can have, never mind, we'll just see this. Okay, one second. Huh? Do they have an example on rollback? No, never mind. Okay, so I think it'll be easier to do it from here. Yeah, actually, let's do it from the terminal. All right. So MySQL. This is, by the way, how you log in. -u stands for the user. Then you proceed that with the username. then -p stands for the password. Don't type your password here. It will prompt you to enter your password. Okay, and you're in. All right. You can see the show databases. Okay, this is what we were working on earlier. This is what we are working on today. So I'll basically use this. All right, use. You can see all the tables here. Okay, this is what it is. All right. Now, let's say I want to insert. I want to do a few things here. Okay. So firstly, I want to find out how many customers there are. Select count star from customers. Okay. And then I want to find out how many employees are there. Okay. Star from, sorry, employees. All right. So, and I also want to find out how many customers are my employees. So I'll say select count. Nah, never mind. That won't help. Okay. So you have 122 customers and you have 23 customers. Sorry, 23 employees. Okay. What I want to do here is let me pick the last two customers. Okay. So select star from customer C, order by C dot. There is no ID here, so we'll go with the customer number. Okay. In the descending order. So every time you add a new customer, the customer number is going to be in, like, from the integers, from the mathematical point of view, the customer's number is going to be higher than the previous customer's number if it is auto generated by the MySQL table. Okay. So we'll say, which means that if your customer number begins like this, 1, then 2, and then 3, if you do it in descending order, you will have 2, 3, and 1. Okay. I just want the last 2. Okay. So the command for this would be order by C dot customer number in descending, so DESC, and how many I want just 2, so limit 2. Okay, I just want 2 entries. Okay, similarly for employees I want to do the same thing, so I'll say,
Sir, you are right. C dot customer is 2 times, sir.
which one? Acha, yes, good notice. Yeah, good, thank you. Similarly for select this thing from employees E, order by E dot employee number DESC limit 2. Okay, what is the matter here? Okay, cool. So you have these customers 496 and 495, and then you have this thing. Okay, what I want to do now is I want to insert a customer who's also going to be an employee. Okay, and I want to delete this particular guy all in one single step. Okay, so what will be the statement for this? First statement to insert into this would be, if we look at our definition here, sales rep employee number, okay, is a foreign key to this employee number, which means first you have to insert into the employee. If you are going to keep a value of sales representation employee number, then first you have to create an employee, then you'll have to create the customer, right? So let's first insert into this thing. What do we want to insert? Employee number, last name, first name, extension. We'll leave these. Okay, anything. I mean, we can just copy paste the value from here. Okay. Insert into employees. What are the columns that I want to insert it for? I want to insert it for employee number. I want to insert it for last name. I want to do it for first name. I want to do it for extension. Oh, is it correct last name? Nope, this is not correct. Okay, employee number. Then you want to have email. Is email not null? Email is also not null. Fine. And then we want to have the office code. What is the definition of office code? Does office code relate to something? Office code relates to offices. Fine, we can pick something else from there. Office code, I'll pick 5. Okay. And what else is there? Office code reports to and job title. Okay. I'll insert a value here. The employee number would be, let's say, 1702. Okay. Last name would be Do. Extension is again extension. I don't think is a. It can be anything. X 1 2 3 4 5. Then you have your email. No reply at xyz.com. Then you have your office code. Office code can be anything like randomly 4. Reports to, let's say, I don't know, like I'll just give a random number 1102. And this guy will be sales rep again. Okay. This is for the insertion of this. Now for customer, I'll say insert into customers. What are the fields I want here? I have the customer number. Then I have the customer name. Then I have customer last name. One second. Okay. Customer name, basically customer last name. Contact first name. अच्छा, contact first name. ठीक है. Phone. Postal code. Okay. The value would be. Actually, you know what? Let me just write this here. It'll be much better this way. I can. Value would be. What is it? Customer number would be 111-000-111. Okay, something like this. And then you have your customer name is as. Last name can be blank or just an empty string. First name, phone number would be, again, this is a string, I think, phone number. Yeah, okay, phone number can be anything, plus 91919191. Validation here. What do we have here? Phone number, address line is address. Second can be null. I mean, this is an empty string, so I can just put it as null. Okay, address line 2, city can be anything, city, state, postal code is 1211515, country is India, sales representative number is what we need. The number we have added here is actually 1702. Is that what it is? No. 1702 is already existing there, so we have to insert 1703. So 1703 3, and what else is there? Credit limit is, let's say, I don't know, like 100.5, something like this. Okay, I'm hoping that the query is correct. And then I want to delete this guy. Okay, I want to say delete from where customer number is, let's say I want to delete this guy. 495. Okay, customer number is 95. Okay. Let's copy all of these. Actually, let's just start the transaction here. So to start the transaction, you will say begin. Okay. Okay. So begin means you are actually going to do you're going to start the transaction. Okay. Let's go and place one by one. Okay. This is one. Query 0, 1 affected. Okay. So at this moment, we are in the middle of a transaction. Okay. And we have already inserted into employees this thing. Did this modify the actual database? Let's check it out. Okay. We will run the same command because we have just inserted into employees, right? So we'll check the employee, the last two. You can see that this has not actually been inserted. Even though this here shows that one row affected, it has not reflected in the database. Okay. These are two different transactions, by the way. This guy is issuing a transaction. This guy is issuing another transaction. Okay. They are two separate transactions trying to work on the same table on the same database. Okay. This is one statement that went ahead and it says one row affected, which means somewhere there is a temporary location where this is already being saved. Okay. Next command here is this command. It again says one row affected. If we run the customer wala part, you can see that there is nothing here. There's no customer by this particular ID. Okay. So which means that this is again happening in the temporary storage. Then you have the last statement, which basically says delete this customer 195. Okay. Acha, cannot delete, update a parent row, foreign key, constraint fails. Acha, right. So you cannot delete a customer because this guy is already having a sales representative number, right? Is it so? Yeah. So let me find a customer for whom this doesn't exist. So let me show another command. Customer order by description. Where sales okay, that's the one, right? Let me just check. MySQL. How do we call select if that is what do we do here? Select last name. Well, a sec. Now, acha, last name is not null. Acha, so not it is null. Okay, where is it? Is null. Okay, let's see what this returns. All right, so we have 2 customers here for whom the sales are business. So let's just say I'm going to delete this guy 480. Okay. So I'll issue the same command again. Oops. Delete from customer 480. Okay. If you do this, again, it shows one row affected. We can verify whether this actually exists or not by running this command. You can see the 480 still exists. Okay. After I have issued 3 commands, this insert, and this delete from here. Okay. If I do commit, okay. Now, if you run this command, you should see that there is no 480 entry here. If you run this command, you can see that there is this large number of customer SFSFS sitting there. And if you run the employee part, you can see that 103 Doe John, this is sitting there. Okay. This is what transaction does. It actually provides a container. In this container, you dump in your statements, and the moment you say commit, it actually goes and starts affecting the rows here. Okay. If you want to do something else, for example, let's say I want to I initiate another transaction. Okay. Okay. Here I have said this insert into customer. Let's say I'm trying to insert one more customer. Okay. With the value 111, and this time, aha. Okay, and this guy does not have a reference to the sales number, so this would be null. Okay. If I execute this thing, range value column customer number, out of range value. I have given some extremely large value here. Change this to this. Okay. You can see query row affected 1, but if you run this, you can see that this is not, there's only one such thing. Okay. If you do a rollback at this point, okay, you come out of the transaction and whatever stuff you did here will not get affected. Okay. If you run this once again, it is still there. So basically what happens behind the scenes, when you initiate a transaction by the begin statement, it basically caches all your query. Okay. It stores the queries and their effect internally somewhere. So you can think of it like this. It basically takes a snapshot of the table and it gives it to you at the beginning of the transaction. Then you can perform whatever operations you have on that transaction. And if you say commit, it is going to merge the temporary database to the permanent database, and you will get the consistent state. Okay. If you do a rollback, then whatever actions you have done in your temporary database will be permanently deleted. Okay. This is what commit and rollback does. You can, if you're interested in finding out how to insert like how to set the transaction levels, the isolation levels, basically, whether it's serializable, what were the levels? Read uncommitted, repeatable read, all those things. You can read this thing, but we're not going to go into these details because this is already taken care of by Spring. Okay, so when you're developing a Spring application, very rarely will you actually be handling transactions manually like this. Okay, you will have a method with some annotation which does this thing for you. In case there is an exception in your method, it will automatically do the rollback for you. In case there is no exception, it will do the auto commit for you. Okay, but I still wanted to give you guys this view here, that I just wanted to show that you can club multiple statements and then you can issue all of them at once, and they all work as a single unit. Okay, any questions on this?
Hello.
Yes, Abhishek.
Yeah, that's command is not running in dev viewer, sir. Only this is working for
No. So the
Yes,
reason
sir.
why why I decided to do the
Yes, sir.
transaction here. I'm telling you. So why I decided to do this here is in your dbeaver, right? You just write the command, right? I mean, you just type it, whatever command you have, and then you basically do the run mechanism from here. You just click on this button and then it basically runs, right? Here, what happens is every command that ends with this colon here is going to be executed. That's why I wanted to show you here. What you do here is you write all your stuff and then you basically run this thing. Okay. I wanted to show you how the transaction actually works. That's why I chose the terminal here. I mean, I could have run this, I could have done the same thing here. Okay. I could have done the same thing here, but it wouldn't be much affecting, right? Because at the press of enter, nothing happens in the database. I immediately come to the next line because it's a text editor. Nothing happens here. No matter whatever bullshit you type and press enter, it will still give you to the get you to the next line. The reason why I wanted to choose terminal is because at the terminal, every enter has a meaning to it. So if you make an enter here, okay, if you do an enter here and then let's say you type this thing and then do an enter, it will give you an error because this is an active CLI. It's an active command line interface. Okay, that's why I wanted to show you here, because every time you insert a query, I mean, every time you execute a query, it basically gives you a result back, which doesn't happen here. Understood?
Yes, sir.
Cool.
Sir, can you repeat the transaction definition, sir?
Acha, so what is a transaction?
Only definition, sir.
That's what I'm saying. So the definition of transaction is it is going to club together multiple SQL statements and it will work as a single unit. Okay. Do you remember that day when I gave you an example? Let's say that a customer who signs up, he's going to register on your database. Then you're going to create a dependent for him. Then you're going to create a wallet for him. Then you're going to add 100 rupees into his wallet, right? So these are at the bare minimum 4 SQL statements. Okay. And the reason why I chose this example was because this entire thing is a single flow. Transactions are basically a single business unit. I mean, these are very high level words. You might get confused, like what is a single business unit and all that. But you need to think from a higher level perspective. Okay, I have an application which is going to let's say Dream 11. Okay, that's a very popular application right now. In Dream 11, you can register yourself, you can deregister yourself, you can play games and all these things, right? But every flow, we call it a flow, right? Every flow, like if you're trying to register here, you enter a bunch of information, but behind the scene, because it's a behind the scene, many different things happen and then you get a response back. If you sign up for something, you see that at the end of the sign up, they actually give you an acknowledgement over email or over a phone number saying that, hey, you have registered with this ID, this password and everything, all those things. So behind the scene, many things happen. So basically this registration flow on any app actually triggers many of these things. It does many things behind the scene. Okay, which means that at the database level also, many rows get newly created or many rows get modified or many rows get deleted. Okay, many things can happen there. Okay, so you cannot think of the you cannot think from MySQL point of view. Like MySQL would say that, okay, this statement is just going to insert into an employee. Okay, if you like, if I give you an example here, customer registration will basically create customer in DB, create customer dependent in DB, create customer wallet, add ₹100 to customer wallet. Okay, these are the 4 steps that are going to happen, right? So what is this? This is your business unit. Okay, your business is defining that if I want to register a customer, these are the steps that must be followed, right? If you think from the MySQL point of view, this is a single insert statement. Okay, this is a single insertion. This is another insertion. Okay, this is another insertion. Okay, and this is an update. Okay, these are the 4 statements that basically need to be individually executed to to have this, to make this thing happen. Okay, but when you think from a business point of view, right, you don't think on the granular level. You don't say that, okay, insert this, then insert that, then insert this, then insert, then update this. This is how you think, right? That in order for a customer to register, these 4 things need to happen. So transaction basically is like a container. It's like a jar. In this jar, you put in your statements and you execute the statements. All of these executions will happen at once. Okay, so transactions are very business oriented, whereas MySQL insertion, update, deletes are very MySQL specific, or this thing. Okay, if your business requirement says that when a customer is trying to delete, when a customer is trying to deregister, you make sure that you delete his wallet, you delete his dependent, and then you delete the customer. This is what these are 3 separate MySQL statements executing in a specific order. That order is basically going to be a transaction. Understood? Because if it did not execute in order, then you would be in a very inconsistent state. Okay, customer would be deleted, but dependent would not be deleted, and his wallet would not be deleted. Okay, so transactions basically wrap this thing around. Okay, transaction does this, it does the wrapping around of these statements, and at the same time transaction makes sure that if any of these statements fails, everything will revert back. Okay, so if your database failed to create the wallet, it would undo the customer dependent creation, it would undo the customer creation, and then it would fail, saying that nothing happened. Okay, so in these 2 tables you will not have 2 new rows. Okay, so what does it do? It protects your database, it protects your table from failures. Okay, how does it do it? Because you can see here it basically deals with 4 tables: customer table, customer dependent table, wallet table. Sorry, 3 tables. Okay, it deals with 3 tables. If this guy fails here and you have already created these 2 rows here, that means you have newly created 2 rows in this database. Do you want them to show in the database? Because what if somebody is trying to do an operation and this customer comes up, but he doesn't have a wallet? It will break your system, right? Because your system thinks that the moment a customer is created, his wallet is also created, but at the time of creation, this part could not execute. Transaction, what it will do is it will make sure that everything that you did before that, all those things are reverted, which means in your database, your tables and everything, they're actually safe. Like before you initiate a transaction, if everything succeeds, you will get a consistent table. As in, if your customer gets created, then everything else, every customer dependent wallet and everything else will also be created. If anything fails in between, nothing will get created, which means at any given point, your database will always have a consistent state. If failure happens, it will have what it had before. If successful, it will have the new thing. Okay, new thing for all the tables. This is what basically transaction does. Understood, Abhishek?
Yes, sir.
I think it'll still be a little confusing for you at this point, but when we start implementing this thing in Spring Boot with transaction annotation, I think it'll be more clear at that point. Okay,
Okay, sir.
cool. If you don't have any more questions, we can end the session here today. All right, good night, thank you very much. Yep.